All right, so next new topic is pressure. If we're dealing with physical contact pressure, um, we're looking at pascals here. It's important to know these are just named after some person from a long time ago, so there's no real clue here, but you can check on your formula sheet, find it in the book, or maybe something you've seen before. Pascals are newtons per square meter, and that's actually a big clue as to how we set this up and what we need to do. If you check the units, you can see where we've got newtons already, and then we don't have square meters, but we have meters and meters, and it says the word area. And as it turns out, pressure can be found if it's physical contact pressure, solid objects pushing on each other, by doing force divided by area. So force is newtons, area is meters squared, and we can see our connections there. We can go ahead and find this area, and then everything will be ready. So it doesn't really matter what we call length and width. We just want to take these different dimensions and multiply them together. And because there are two of them, we get meters squared. From running those through, looks like 0.12141. And then now we can get an answer. So the force has been sitting in the question the whole time. That's there in newtons, the area we had to go find, but we've got that now. Remember that newtons divided with square meters is the definition for pascals. So that's automatically going to work out. Dividing these, we get 67,465.61, which seems like this would be a really big pressure because it's a big number. But as it turns out, pascals are just very tiny units. So atmospheric pressure, because you're on Earth and there's an atmosphere, is over 100,000. So if we convert this to psi, which you might be a bit familiar with, we get something like 10. And so you probably know if you had only 10 psi in your car tires, that would not be anywhere near enough.